Good evening and welcome to the Oliveboard platform. My name is Marut Sharma, your logical reasoning expert, and we are here today to start this wonderful, cute little session of directions. So we'll start it today and we'll end it today only. We'll practice some decent questions also in the later half of the session. Good evening, guys. So let's start right away without wasting any further time. Now, a few insights I want to give you about directions before we start. So direction, blood relations, your puzzles, sitting arrangement, order, ranking, Venn diagram, syllogism. We put it generally in the same category of logical reasoning. Though technically there are differences, but we put it in the same category where what exactly is the method of dealing or the principle behind them is that you observe the question. There are some instructions, there are some information given to you. You convert those instructions, that information into the form of a figure for easy visualization, and then you solve the question. That's the whole idea. And precisely that is what, that is the ground on which all of these types are based. So the basic principle again is the same, but the front end, the facade of the question keeps on changing. So direction is one such concept, and under direction, you need to have some prerequisites. Again, you need to know some things by hand beforehand, before you actually start understanding the concept and start solving the question. Though, as far as the difficulty level is concerned, directions are not very difficult. The questions are very direct, very easy, very to the point. But if you understand the concept well, and if you are clear with some issues in directions, common issues the students face, left, right, etc., then you can actually give much faster answers here. So that can be beneficial. When I talk of direction, well, if we talk of the general frequency, directions frequency has come down a lot. So seldom do you see questions now for directions in any examination. Even in SSC exams, you'll see direction questions very limited only. But still, I mean, nobody has said that direction will not be a part of your syllabus at all. So of course, we need to cover it no matter what. 4 major types of direction based questions we'll be covering. So the first one is your path tracing method. Majority of the questions are based on this very method only. Now what we'll do here is a quick revision, because this is a crash course. Quick revision. In this one single slide, I will cover the complete directions with you quickly, briefly, and then we'll start solving the questions. So we'll first talk about path tracing. Any issues you have, any problems, you can put it in the chat box right away and I'll be more than happy to assist you. So path tracing is one of the basic and the most common methods used to solve directions. Now, multiple students, you might have learned at different places and you have that notion that, the shorter the method, the better it is. Well, that is true, but that is only partially true. Because the problem is that you have a lot on your plate. You have to cover reasoning, you have to cover quant, you have to cover GK, GS, you have to cover English, you have to cover now computers. Okay. So the issue is that, let's say if I have 6 different type of questions in this topic, let's say, and I have 6 methods, one method for each topic, which is the shortest method. So you will end up learning 6 different methods, and to get accustomed to those 6 methods and bring them into your system, it is going to take 6 times more effort. Rather, if you find one method, which at a time might consume slightly more time, but overall, if you can practice that one method on a span of all the 6 types, that one method is applicable everywhere, and then you master that method, you will end up saving much more time even in your preparation phase. So that is the basic idea. Okay. Now, looking at path tracing method, what exactly happens is you follow the instructions like you have a board game. So you throw a dice, you get a number, you move your pegs accordingly. So here the dice is replaced by the instructions of the question. According to the instructions of the question, you'll be keep on moving a peg. So you'll draw a figure, and based on that rough figure, you'll generate your answer based on directions and distances. Path tracing is further divided into 2 parts, 2 types of path tracing: square and rectangle method, or the Pythagoras theorem. And you can either use one of them or both of them, depends on the type of question. Now, what exactly happens here is that you need to be very careful, or you need to be aware about the directions. So in this chapter, you will be learning, or you will be looking at directions from 3 different perspectives. Perspective number 1 is your regular direction set. The 4 main directions: north, south, east, west. And then we have cardinal directions, so directions in between them. We also call them cardinal directions. So, and we label them. How do we now name them? The vertical direction first, horizontal direction next. So this is northeast, this is northwest, this is southeast, this is southwest. Now an interesting factor here is that if I talk of angles, so an angle between any two main directions, consecutive main directions, will be 90 degree, and the angle between any two consecutive cardinal directions will also be 90 degree, and an angle between a main direction and a consecutive cardinal direction will be 45 degree. Be careful about the angles. So this is the first set of directions which you need to be aware of. Now the second set is, if you look at this as a clock, okay, so this is 12 o'clock. After that, what will be the time? 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. That's how the clock will move. So this is in the direction of the clock. We call it clockwise. And after 12, immediately we cannot have 11 or 10 or 9 or 8, right? So this is opposite the direction of the clock, which is known as anti-clockwise. So clockwise and anti-clockwise. So this is the second set. First set is these directions. Second set is anti-clockwise and clockwise. Third set is the classic left and right, which most of the students struggle in. Now left and right changes as per your facing direction. So if you're facing in the north, this will be your left, this will be your right. If you're facing the east, this is your left, this is your right. Facing the south, this is your left, this is your right. If you're facing the west, this is the left, this is the right. You'll observe that in every case when the direction switches completely from north to south or east to west, the left right will change their positions immediately. You need to be well aware of this. Okay, your left and right should be absolutely clear. So you can take help with your own left and right, your right hand and your left hand. That will be more helpful for you. And imagine wherever the arrow is, you can imagine your head in that direction. So right and left hands will give you accordingly. If you have a problem, otherwise it's good. Okay. And the same left, right, northwest concept we will also be using in sitting arrangement. So there also this acts as a variable. Now what happens is we'll be tracing the path. So in your path tracing, your figure will always, which will be drawn, will be always to scale. Your figures will be to scale. That means if I'm drawing a line of, let's say, 150 meters, and then I'm drawing a line of 100 meters, so my 100-meter line has to be slightly shorter. And if I'm drawing, let's say, 50 meters now, so the 50 meters has to be roughly half of 100 meters. Not exactly, you don't have to use a scale, but roughly half of 100 meters. Initially, if you are newcomers, if you're starting this topic for the first time, or if you don't have a lot of exposure, then you can draw larger figures with a lot of volume in between, with a lot of space in between, so that it's very clear to you that what exactly is happening. But gradually, as and when you progress, you will become more and more fast in tracing the figure, and they will become smaller and smaller, so that you get your answers very quickly. Now, let me give you a situation. So somebody from their house is moving 150 meters in the north. So you'll first start labeling. So this is the house, okay, and they are moving 150 meters in the north. So okay, so they have taken a 150 meter north track. So that's how you'll draw it. Now they're turning towards the right and going 100 meters. So you'll slightly draw a smaller, shorter line here. They have turned towards the right here and they are going 100 meters. 90-degree only turns will be there. Then they'll turn towards the right again and go 50 meters, or rather let's say 30 meters. So they'll turn towards the right and go 30 meters. So this line has to be slightly shorter than 100 now, 30 meters. Now they're turning towards their left and they're going 40 meters. Okay, so turning towards their left and going 40 meters, and they're stopping there. Okay, so they are saying now the person moved from his house, went 150 meter north, then took a right turn, went 100 meters and stopped at the coffee shop. That means this is the coffee shop. From the coffee shop, he went 30 meters south, took a left turn and went 40 meters and finally reached the library. The question is, what is the shortest distance between the coffee shop and the library? Okay, so now you've drawn the figure. What you'll do is the shortest distance between them implies this distance. You will not add 30 and 40. You will take this distance. Now this angle is 90 degree. Why? Because this is south, this is east. So angle between them has to be 90 only. Okay, so this is a right angle triangle with 30 and 40. So by Pythagoras theorem, you will get this to be as 50. So this is the minimum distance which was required between the coffee shop and the library. You have to understand one more point here, that Pythagorean triplets should be there with you. So by now, this is a crash course. I am assuming you are well aware of the Pythagorean triplets. The list of triplets, common triplets you need to remember, because questions will be asked where you might have to apply a Pythagoras theorem and you will not have the liberty of the time to actually solve it. Now, the question is further asking me, in what direction is the person currently from his house? So currently from his house, if his house is here, let's say, so I'll draw a plus sign here where the house will be in the middle of the plus sign, and I'll see where is he. So he's in the northeast. Where is his house with respect to his current location? So you'll draw a plus sign here and you will see which direction it is, southwest. And which direction is he currently facing? So like I told you, this is like a board game and you're only moving it on the instructions. You cannot move it, or the person cannot move on their own free will. So the final instruction was for this person to come to reach the library and stop here. Where was that direction? That direction was facing the east. So where is he currently facing now? He is still facing the east only. So the person is facing the east. That's the whole idea. This is precisely how you solve a path tracing question. I showed you Pythagoras theorem also, and this is square and rectangle. If let's suppose from here now I tell you that now he decides to go back on this same path, he goes 140 meters. So now 40 meters and 100 meters more he has gone, and he has reached another point, let's say X. Now they're asking you how far is X from H. So what will you do? You will see 40 and 100. So this is a rectangle actually. Why? Because again north, east, south, west. So they are all 90 degrees. So quadrilateral will all 4 angles 90 degrees is a rectangle. Opposite angles or sides are equal. So this is 100, this is already 100. So this is 30, this has to be 30 only. Okay. So the whole thing is 150. This is 30. Subtract, you will get 120. Right? But each time you don't have to prove it to be a rectangle. Everything else now is here. It's all visual. Immediately you will trace it and give your answers. Right? So that is precisely the complete set of path tracing, which you need to understand. And majority of your questions, even if you look at the previous year questions, they are all from this section only. Majority of the questions in any examination from directions will be in this region only. Okay. Now, we'll move on to the next concept, which is shadow based. Shadow based also we'll draw a figure only, but we might not have to trace the whole path. We can draw a very small figure with 2 arrows and maybe get done with it. Right? In shadow based, what happens is you are given some instructions, some information is passed on to you, but you need to gather, you need to pick up that information. It's not obvious, it's not clearly visible, it's all hidden, it's implicit. So you need to pick up that information, and from that information understand the whole scenario, and then they will ask you a question which you need to answer. So let me break it down for you one by one. The first thing which they will give you will be a keyword. They will usually start with a particular keyword. What will the keyword be? What can the keywords be? So they will have options like morning, evening, they'll say sunrise, sunset, or they'll give you a time, 6 a.m. in the morning, or they'll say 6 p.m. in the evening. Any of these keywords they can use. What is this keyword giving you? The question will start that at sunrise something happened, or in the morning something happened, or at 6 a.m. this something happened, or at sunset this happened. Whatever is happening, but when is it happening becomes an important point for you, because this gives you the direction of sun. This gives you the direction of sun, and it is only two possibilities here. Either it is east or it is west. Why? Because shadow based means we are going to talk of shadows. For shadows to be generated, you need a light source. That light source mostly in these questions is the sun. Now if the sun is in the north, that is probably 12 noon or exactly in the afternoon, let's say. So if the sun is in the north exactly above your head, you will almost always not see a proper shadow, at least in the reasoning section. Maybe in science you can see a small shadow here and there, but we are not going in that detail. So hence we don't consider the sun to be in the north or south, of course not. So we look at east and west only, and that you will pick up from these keywords. So if it says morning, if it says sunrise, if it says 6 a.m., that means you are talking the sun to be in the east because sun rises in the east. And if you're talking about evening, sunset or 6 p.m. or any p.m. at the evening, we are talking about the sun being in the west. So this gives you the direction, the location of the sun, the location of the light source. Now sometimes what they can also do is, rather than giving you the sun, they will give you a definite light source. They will say sometime at 10 o'clock in the night, in a well-lit hall, light source was placed in the west. A very large light source was placed in the west. A large bulb or a large, light eliminator or something. And then the rest of the question follows. So in that case, time, etc. is not mattering because you already know the direction of the light source. Light source is important to generate a shadow. Second set of information, they'll give you about two people. Two people, and they will always be in the opposite direction. What does this imply? So they'll tell you that two people are either walking away from each other or they are walking toward each other. Either they are walking away, see they are still in the different directions, opposite directions, or they are walking toward each other, still they are in opposite directions. They will never be walking in the same direction, because then the light source will generate shadows in the same direction only, and you will never be able to get a particular question. Okay. So they'll give you either of these scenarios. How can they present it? Either they'll be walking in the separate directions. That means I'm walking towards somebody, that somebody is coming towards me. Or I'm walking away from somebody, that somebody is also walking away from me. Or we are sitting facing each other, or we are sitting in a park with our backs facing each other. Anything, but this is the scenario which is given to you. This is second set of information. The third set of information will give you the direction of shadow. Direction of shadow. This will be given to you. For example, I'll formulate a question for you. Let's say early in the morning, two people, A and B, are sitting with their backs towards each other, and the shadow of A falls to the left of B. Shadow of A falls to the left of B. So these are all informations given to you. Finally, they will ask you the question. So this is what you need to answer. For this, you need all this information beforehand. So let me give you a random scenario. I'm saying in the morning, two people are sitting with their backs towards each other. That means this is the direction. And A shadow left of B. A shadow is left of B. So I've given you the direction of shadow. My question is, B is facing which direction? My question is, B is facing which direction? Right? So how will I identify this? I'll quickly draw the sun. So in the morning means sun is in the east. Sun is rising in the east. So these are the sun rays coming in this direction. We have two people with their backs facing each other, backs towards each other, something like this. Now, their shadows, where will they be formed? In this direction. Both of their shadows will be here because the sun rays are coming from here. Now the question is saying A shadow falls to the left of B. A lot of people now here, they stop, they slow down and they try to identify, okay, A shadow, this person's shadow is towards this person's right. No. This person's shadow is towards this person's left. A shadow is to the left of B. So this is A, this is B. That's how they find it out. But for each question, it's going to change and it's going to be difficult for you. So what is the easier method? You will see that A shadow is to the left of B. Look at the shadows. These shadows are in the same direction. For the person who is facing the north, facing the above, shadows are towards his left. For the person facing the below, shadows are towards his right. We need the shadows to be on the left. So left hand side of the person above. So this is B. This has to be A. Okay. Now the question ends with asking which direction is B facing. So we'll say B is facing the north. So that's how we solve this question. Okay. Eventually in the examination, you don't have to draw the sun, the rays, etc. everything. No, that's not required. You just have to draw these two arrows. These two arrows will precisely give you your answer. That's it. Everything else has to be visualized. Everything else has to be in your head. Right? So that is how we solve a question of shadow. Shadow based question. Next is angle based. Remember, in shadow based, you can also have your shadows. Direction of shadow can be left, right, or front, back also. Why? Because I can also place my people like this. In that case, if the sun is here, their shadows will form like this. For one person, it will be in the front. For the other person, it will be at the back. But it is very rare. It has never been asked in an SSC exam. Once it has been asked in a railway based exam. But you need to know that this is also possible. It's not always north and south. Okay. Now we look at the angle based question. Once again, yes, Sushma, sure, why not, beta? But which part? The whole thing or some particular part? You'll have to let me know. The whole thing or a particular part? Okay, let me take you to the next page only. Yeah. Okay. So I had said that in the morning means sun is in the east. This is my sun. My sun means our sun, of course. S-U-N, sun. It's in the east. And this is acting as a light source. So these are the light rays. Okay. Now we are talking about two people sitting with their backs towards each other. So this is how they are sitting. The rays are coming from here. Now, where will the shadows fall? When the rays are coming from this side, these are the objects, the shadows will form this side only, no? So we'll have the shadows in this direction. The question said the shadow of A falls to the left of B. Shadow of A falls to the left of B. Rather than calculating everything, just see on whose left the shadows are. For this person who is facing on the north, the top, both the shadows are towards his left. For this person who is facing the south, both the shadows are towards his right. Shadow of A is to the left of B. So we need person whose left the shadows are at. This is B. This has to be A, left of B. Shadows are to the left of B only. Now the question asked in which direction is B facing? So B is facing the north. So that is my answer. That is how I will solve the question. Yeah, Shushma, is it clear now, beta? Okay, now if the question said in the evening, so the sun can go in the west, then my shadow directions will change. So then my answer will accordingly change. Okay, perfect. So this was shadow based. Now we come to angle based. What happens in angle based? In angle based, there will be a starting direction given to you. Let's say a person is facing the north. Let's say a person is facing the north. Now your question will tell you that the person is now moving 90 degree clockwise, 180 degree anti-clockwise, 135 degree clockwise, 225 degree anti-clockwise. Okay, and again 90 degree clockwise, 45 degree anti-clockwise. Now where is he finally standing? For those who don't know this, what they do is they will start from north and they'll start plotting these angles one by one. That will end up consuming a lot of time. So what do is we draw a single table, clockwise and anti-clockwise. Write all the clockwise angles at one point, write all the anti-clockwise angles at the other point. So let's say the question starts with I go 90 degree clockwise, I go 180 degree anti-clockwise, I go 135 degree clockwise, I go 225 degree anti-clockwise, then I go 45 degree clockwise, and I finally go 90 degree anti-clockwise. This is what I'm doing. Okay. Now I need to find the final direction. Where am I facing? So what is the first approach? The first approach is after drawing this table, you will cancel out all the angles which are common in both the cases. Like the 90 and 90 will get cancelled here. Because 90 degree clockwise movement and followed by 90 degree anti-clockwise movement, net movement is 0. So that is not going to create any effect. Now you will find the total of all these angles. So you will see this is 180 and this is 405. Okay, and if you now subtract both of them, larger and smaller, so you will get 225 as your answer, and you will take the direction of the larger one. What is the direction of the larger angle? It is anti-clockwise. What is this known as? This single value is known as single net movement. This is known as single net movement. What does this do? Now, rather than moving all these pegs, all these directions, all these angular movements, you will move this single angular movement and everything will remain the same. You will get your answer. So if I'm starting from the north, I just have to travel 225 degree anti-clockwise. Okay, 225 means greater than 180, less than 270. So this is from here, anti-clockwise, sorry. So from here it will start and it will end somewhere here. So it will end somewhere here. From here it will start and it will end somewhere here. This is what is happening. Finally, which direction is the person facing? It is southeast. So that is how you will solve the question. Got it? This is your angle-based question. Now, so far in your SSC exams, you will see questions only from these categories. Okay? You will see questions from these three categories majorly. You will almost never come at this position. Angular turns. Okay, but you need to know this. This can be used as a fact against you in an exam and then it will become difficult. What happens in an angular turn? So generally, the question tells you no person is going in the north and turning left. So generally, we take a 90 degree turn only. Turns are always 90 degrees by default. Okay, turns are always 90 degrees by default. But they can also be based on particular angles. Supposedly, I'll give you an example. A person goes 10 meters north, then takes a 135 degree left turn. and further goes 5 meters. He now takes 45-degree right turn and further travels 5 meters. In which direction is he currently moving? Simple question, very easy question, just for you to understand the angular terms. Okay. So my question is starting here. I am saying that there is a person who is going 10 meters north. So we'll start from a particular point, let's say here, and I'm taking him 10 meters north. So this is 10 meters north. And we have stopped at this point. Till the time we get further instructions, we have stopped here. Now the question is saying, now he's taking a 135 left turn. So far for me, left turn was immediately I turned here and we started moving ahead. But this time there is an angle involved. 135 means what? Should I take him this way or this way? Where do I go? Now by default the turns were 90 degree, but a lot of people have a misunderstanding. It is not this 90, it is usually this 90. This becomes 90 because of linear pair. That means, what is the basic thing which we require to make an angle? We require two things. One is the origin, the starting point, and the other one is a baseline. Okay, so this is the starting and this is the baseline. What is the baseline? The baseline would have been that direction in which the person would have gone if he wouldn't have turned. Continuous motion. Okay, now this is your baseline, this is your origin, and this is your baseline. Now this is left side, this is right side, because the person is going north. So this is left, this is right. We have to move 135 left. So on this baseline, construct an angle of 135 degree. That is what you're going to do, 135 degree. Okay, and you're going to go 135 degree and you're going to go 5 meters. So this is what will happen now. So this angle here is 135. So the person actually, he came from here and then he turned like this. This dotted line is not supposed for you. I mean, this is not a line of his motion. But this is just for you to understand that this is the base on which the angle was constructed. So he moved in this direction. This is a 135 left turn. Okay. Now from this position, this person is now taking another 45 degree right turn. So again, if I extend this further, this is my origin point and this would have been my baseline. Again, for this direction, this is the left and this is the right. I am taking a 45 degree right turn. So this is the 45 angle I need to construct. So I'll construct that 45 degree angle and I'll further go 5 meters. So this is the 45 degree angle. So precisely this is how the person is moving. Okay. If you want to check it out by this method, you see 135 left and 45 right. So what is the net movement? Net movement is larger minus smaller. So we have 90 and the angle, the direction of the larger one. If you clearly observe, the person was going towards the north and he just took a 90 degree left turn. Finally. You see, so 135 left and 45 right actually added up to 90 degree left turn eventually. But you can't draw it like that because this motion is important for you to trace a path if at all a question has been asked accordingly. Right? So this is how you trace angular movements or angular turns. If at all it comes your way, you can solve it like this. Okay? Yes, correct. Absolutely right. The final direction of movement is west. So this is directions. I told you just in one slide, we will revise it completely. Okay? 30 minutes we took and we are done. We'll now move on to the questions. First question in front of you. Answers in the chat box, everybody. They're interesting questions. Not very difficult, but not very direct also. So you will have fun. Quickly start putting the answers in the chat box, everybody. So what is happening here? Mohan's house is 400 meters north of Radha's house. This is actually a very good question. Okay. Mohan's house is 400 meters north of Radha's house. So if this is, and I'm drawing a small figure here, you will start drawing a bigger one. Gradually you can, cut short on the amount of space you take. Okay, so this is Radha's house and this is Mohan's house, and there is a difference of gap of 400 meters between them. Be careful now, okay? Both walk 100 meters north from their homes. So Mohan goes 100 meters north and Radha also comes 100 meters north. So this is Radha's new position, this is Mohan's new position. But despite that, after moving 100 meters, they still have a gap of 400 meters between them. Right? Mohan turns left, okay, and goes 200 meters, fine. Turns left and walks 350 meters. Be careful again. This is from this to this point. From this point here to this point here, it is 400. So by 350 is almost coming at this position. This is Mohan's school. This is 350. So 50 is still left from here to Radha's position. 50 meters is left. That is your visualization. What about Radha? Radha turns right and walks 350 meters. Then takes left to walk 50 meters. Now 50 meters means she has now come at par the level of Mohan's school. This is Radha's school. Radha's school and Mohan's school are at par with each other. That is precisely what you need to understand with this figure. Otherwise, you'll end up making an error. Because after moving 100 meters in the north, each of them, they still had 400 meters difference between them. And now this movement has happened. The question is simply asking you what is the minimum distance between their schools. So if this is 200, this is also going to be 200. And if this is 350, this is also going to be 350. 200 plus 350 is 550. Option 3 is the correct answer. Very easy question. Very easy question. Just the formulation, the visualization is what takes time. Okay, perfect. Next. This is even easier. What is happening here? A person starts from point X and walks 6 kilometers east. Turns left and walks 3 kilometers. Turns left and walks 5 kilometers. Now 5 means he's slightly before here. Okay, this is 5. Then turns right and walks 2 kilometers. Finally turns left and walks 1 kilometer. He has already come 5. 1 means he'll be in line here. So this is Y. They are asking you how much and in which direction should he walk to return to point X. Okay, so 3 plus 2, 5 kilometers in the south. So option A is the right answer. Option B. Okay, gradually you'll realize that in the options you can either find out the distance or the direction rather than finding both of them. With that you can eliminate options and get to it faster. Shalika walks 15 kilometers south from her house. This is Shalika's house. She is going 15 kilometers south. Then turns east. Now east means there is no left right here. Some people, they will feel that if she is moving this way, so now east will be here, west will be here. No. East, north, south, west, they are all in the same directions only, always. I don't have to draw this again and again, but this is what you need to understand. So no matter what direction she is moving, east means this only. But left and right can change based on her face. facing direction. So she turns east and walks 10 kilometers. Then turns north and walks 25. So she's already going 15 and she's going 10 more. Make these calculations here only in your head. Don't write it down, but make it in your head because this is actually very useful. Finally turns west and walks 15 kilometers. 15 means she's already going this 10. And she's going 5 more. But the question is now asking you in which direction is she now from a starting point. So very easy question now. So she's right here and starting point, which direction is she now? Northwest. Now see out here, if I'm drawing it one by one and showing it to you, it's actually taking time. But gradually you need to cut short on the time. Okay. So you can quickly draw this and get your direction very easily, just without drawing or looking at anything else. Just quickly look at this and you'll get to figure it out. Okay. Next. Now Mohan is at a railway station in a district. He wants to reach the nearest bus stand. Okay. He walks 120 meters east. So if this is the point, he's going 120 meters towards the east. Turns right and walks 100 meters. Then turns left and walks 30 meters. Again turns left and walks 140 meters. So he's already going 100 and he's going 40 more. Where he meets his friend. So this is his friend. Finally turns left and walks 150 meters. 30 plus 120 is 150. So he'll come exactly here, right on the top. And this is the bus stand. This is the railway station. The question is, what is the distance and direction of the bus stand from the railway station? So it's north and it is 40 meters north. Option 4. Easy. Next. So Priya leaves her house and walks 29 meters north. So this is Priya's house. And she walks 29 meters north. And then 16 meters to her right. Now she turns right again and walks 17 meters. So 17 meters means less than 29. Okay, make sure you draw it like this. She again turns right and walks 21 meters. So this is how she's going. 16 and 5 more she's going from here. This is 21 meters. Before stopping. So she stops here. What is the minimum distance between Priya and her home? This is Priya's current location and they need to find this direction. This distance. So if this whole thing is 21 and this is 16, that means this part is 5. And if this whole thing is 29 and this is 17, that means this part is 12. We need to find this. This is a 90-degree angle. So I'm just drawing this for you. You don't have to draw it here again, but this is what has been given. This is need to be found out. So this is Pythagorean triplet 5, 12, 13. So what is my answer? Option 3. Easy. It's sometimes either only Pythagoras theorem or only square rectangle or a combination of both. This is again an extremely easy question. Ritu drives 2 kilometers south from point A. So this is point A. She is driving 2 kilometers south. Then she turns right and drives 2 kilometers. Then she turns right and drives 2 kilometers again. Finally, she turns right and drives 4 kilometers to reach point B. The question is, how much distance and in which direction should she drive to reach point A? So she has to drive 2 kilometers towards the west. If you look at the direction with west, you have only one option. So that will be your correct answer. Okay. Next. So look for the distance or direction that can be picked up from the options. If you look at the 4 options right now, you can see that the distance is actually different in all the 4 cases. We still have direction repeated twice. So just find out the distance. That will give you the correct answer very quickly. Okay. Vimal starts from point A and walks 8 kilometers east. Then turns right, walks 9 kilometers. Again turns left and walks 12 kilometers. Then turns left and walks 17 kilometers. So 9 plus 8, 17. Finally takes last left turn, walks 20 kilometers. 8 plus 12 is 20 and stops at point B. How much distance in which direction must he walk to return to point A? So 17 minus 9, 8 in the south. But we know 8, we just found out 8 and we know option 3 has to be our correct answer because that we had decided beforehand. So reading the options can always be helpful. Looking at the options, it is quite clear that this is Pythagoras theorem. Okay, a man starts from point O. A man starts from point O. Walks 20 kilometers east to point A. Make sure you keep labeling everything. Okay. Turns right and walks 10 kilometers to B. Okay, I have to draw it again. Turns right and walks 9 kilometers to C. 9 means he's only coming till here, let's say. Then turns right and walks 5 kilometers to D. So half of this. Turns left and walks 12 kilometers to E. 9 plus 12 is 21. So this is slightly going ahead here. But the question is saying finally turns right and walks 6 kilometers to point F. Sometimes, read the question beforehand. This was actually not required. So anyways, he has 10 minus 5 left with 5 here. So he's going to go 1 kilometer ahead and he's going to reach F here at 6 kilometers. The question is asking you what is the shortest distance between E and B. So if you wouldn't have labeled it, this one would have gone. Okay. So you'll have to complete this figure like this here and join these two. So we are actually looking at this right angle triangle. Okay, this is point E, this is point B. Let's not label this point. I mean, this can be any random point. It's not given in the question. Now, we need to find this out. This is a right angle triangle. We need to find EB. So what is this distance? If this is 5, This also has to be 5. So this is 5. And this is 9. This is 9 and this is 12. So this is 21. So what is this? 21 square plus 5 square. 25 plus 441 is 466. So this is root 466. So option 2 is the correct answer. Of course, with unit digit also you could have found it out very easily. Right? So this is my right answer. Cool. Next. Money starts from point A and goes 5 kilometers west. So money starts from point A and goes 5 kilometers west. Then turns right and drives 8 kilometers. Then turns right and drives 13 kilometers. So 5 plus 8, 13. Turns right and drives 19 kilometers. So 8 plus 11, 19. Turns left and drives 4 kilometers. Finally turns left and drives 11 kilometers. Now we know what is the game. So where will it land? It will land right here. This is point B. Question is how much and in which direction should he drive to return to point A? So he should drive in the west direction. With west we have only one answer. So option 4 is the correct answer. Okay. Of course he's driving 4 plus 8. 13 minus 5 is 8, no? So this much is 8, this much is 4. So he's driving 12 kilometers west, but we did not need the distance. We had the direction which gave us the quicker answer. Next. See, these questions are actually very easy, and these are the kind of questions which have been asked in the past, in the recent past. If at all you see a direction question, it is usually going to be based in this region only, right? So for quicker practice, for faster approaches, just practice these questions and get a hold of your figure making skills and your visualization. It's majorly all about visualization. Shiv started from his office and walked 15 meters south. This is his office. He walked 15 meters south. Then turned right and walked 20 meters. Then turned right again and walked 15 meters. Finally turned left and walked 15 meters to reach his parking spot. Okay. How far in which direction is the car from the office? So the car is in the west. And how far? It is 20 plus 15. 35 meters west. Option 3. Okay. Next. This one is actually very easy. Directly you can do it. A person walks 9 kilometers north, then turns left and walks 4 kilometers, again turns left and walks 10 kilometers, again turns left and walks 4 kilometers. How far is he from the starting point? 10 minus 9 is 1. So see, this is what happens in terms of figures. If you get quick, you can actually solve the questions very quickly with the same method. With this one method, you can solve any type of direction based question. No restrictions whatsoever. Q walks 100 meters north. Turns right, walks 150 meters. Turns right, walks 170 meters, 100 plus 70. Turns left, walks 80 meters. Finally turns left and walks 70 meters. 170, 100. So he's only 70 here. He'll come back at this level. And how far, at which direction is he from his starting point? He's in the east. Okay. Okay, wait. This is west 200 meters, west 200 meters, east 230 meters, east 250 meters. So obviously west and west would get cancelled. And if you look at the direction here, 150 plus 80 is 230. He's in 230 meters east. Generally, they're all translated, but sometimes, you know, the options can just remain like that. Next. So this is 20 foot west, 20 foot east, 20 foot west, and 20 foot southwest. If at all you don't know the Hindi directions, I'm just writing it here. So these are also kinds of questions where you will plot everything quickly and then find the answers. Good job with answering, everybody. Arunima, Shushma, Naresh, Manoj and Naresh, I think they are my regular students. SFK, Aditya, Harshini, Sri Juruni. Good job guys. Very good. Excellent. That's the consistency I'm looking at. Any sort of question, practice is always good. E is 5 feet south of Q. So if this is Q, 5 feet south of it is E. K is 5 feet west of Q. So equidistant. L is to the east of Q. I is 15 feet east of E. We don't know whether L is more or less, but at least we'll draw this as 15 feet east of E is I. How far, in which direction must a person walk from I to reach V, which is 5 feet west of E? Oh, this is very easy. 20 feet towards the west. Right? Easy question. So they had just given you this data to confuse you. It was a very easy question. Next. Now, this is where I want you guys to understand. I had taken this session somewhere else also, and they had said that, you know, drawing a diagram these days takes a lot of time. So if you have a shorter method, you can teach us. So as I was telling you, for every different type of question, there is a shorter method. But learning a shorter method for each different type, or learning one method which works everywhere, I think personally the other one, the latter, is better. If you have the one method which is perfected many times, practicing for different types of questions, just apply that single method and get your answers. There is another method here which we'll talk about. Okay. So look at this question. A man is running 20 meters east and is turning right. So from here he is running 20 meters east and then is turning right. Then runs 15 meters and turns right again. Okay. Then runs 10 meters, turns left, runs another 10 meters and turns left. And then runs 20 meters. So 10 plus 10. Once again turns left and runs 12 meters. So this is 10 and 2. 12 meters. What direction is he facing now? He's facing the north. Okay. Now just look at this one. Okay. In a type of question where the distances are not important, in the end they are only asking you the direction, but not a direction from a specific location, a direction of facing. Then what you can do, you can, rather than going here, you can remember the simple rule. It is always going to turn left and right only. Okay. So if a person is turning two lefts, continuous lefts, you will see them two at a time. So two consecutive lefts or two consecutive rights will turn the person 180 degree. So you will just give it a 180 degree flip. If you're moving like this, you just start moving like this. If you're moving like this, just start moving like this. Okay. And if it is a single left and a right, or a single right and a left, then there is 0 degree movement. There is no net movement. You will cancel that movement completely. Now look at this. Let's start. Okay. Man runs 20 meters east. So he's starting in the east. He's starting in the east. We are looking at his facing direction now. then turns right again, turns left, once again turns left. This is the final movement. Now read them two at a time. Two rights means now he's from the east, he's going to the west. Two lefts means from the west he's again coming at the east. And final left. From the east, if he's taking a left, which direction is he going? North. That's your answer. So you can do it with this method. Now, as beautiful as this method seems, if I place two of you together and if I ask one of you to solve it with this method and the other one to solve it with this method, maybe there will be a minute difference of a second here and there. So sometimes, you need to learn about ROI. What is the return on investment? How good can I actually, how much can I benefit from practicing a new method altogether? Because sometimes it is just fancy. It is just used as tricks to, make you feel, oh, wow, this is something new. Wow, what a good teacher. But actually it ends up wasting your time unnecessarily, right? So that's the idea precisely. Exactly my point. So I prefer this one only, right? But again, the choice is yours. See, I have to share it with you. I don't want to hide anything. So this method is also there. You can use it very clearly. If you're comfortable, go ahead. If not, you can drop it. Next. So we'll keep this as the last question for today. And then we'll wind up the session. And I'll see you guys again in another session with a new topic. Cool? Last question for the day. Yeah, with number it does not work. So you have to be very type specific. When you read a question, you see that there are no distances which are involved in the terms that the question is not asking you about distances. It's only asking you about the final direction and that to the facing direction. Then you can use this method. Okay. But again, see, that's the choice. Each time you'll have to remember the type. Then you'll have to see whether this type is fitting or not. Then apply that different method. Rather than that, stick to one. That's the best approach. So oftentimes, students get carried away with wow factors. But they don't understand that what is the final implication of that method or that factor in their examination. Is it actually helpful or not? Good job. Very good. Quick answers. Girl walks 20 kilometers south from her home. Turns left and walks 26 kilometers. Turns left again and walks 37 kilometers. So 12 plus 25. She then turns right and walks 6 kilometers to reach her office. Which direction is office from her home? Oh, couldn't have been easier. It is northeast. Option 3. Cool. So with that, we'll end the session here. Thank you so much for watching till here. I will see you around in the next session with a new set of topic, with a new set of questions, practice questions. Till then, you guys take care. Bye-bye. Namaskar. Jai Hind. Most welcome, bacha. Take care. Bye-bye. Bye, guys. Most welcome. Thank you. Have a good evening. Bye.